Artificial intelligence, neuroscience, computing and bioengineering are all weaved together here at the Brain and Behaviour Lab at Imperial College in London. Once again, I volunteered to throw myself into the demonstration. I feel bionic right now.
It's very cool.
Covered in sensors, 17 of them. From this moment on, everything I do will be tracked. My data will be recorded. I'm in the system. All these sensors, they know where they are in the world.
Exactly. So that's what we call a body sensor network. So all these sensors talk to each other via our wireless access point. And so they will say each other, hey, I moved up. And this sensor will say, oh, I moved down, and maybe means that I did something like this. And so that's from talking to each other, the sensors work out what the body is doing. Because ultimately we're not interested in this data of the sensor, we want to know how's your pose in the world.
So I've now been calibrated.
You're now calibrated,
so now it
that's
knows
your digital twin.
My digital twin! I have a twin! I mean, Aldo, there is a lot of data being generated here.
Correct.
Can you explain what it all means?
Yeah, so let's remember that what the AI sees is not the picture of you. There's no camera recording things. You're wearing sensors. And these sensors are recording how your position of the body is. If you just stand still like this next to me, Shini's standing still because nothing is moving. It's a flat line. Yeah, it's old still. And then now, Shini, maybe you can just do this with your right elbow. Okay, and now we're seeing here that this is the right elbow, and this goes up and down periodically as she's pumping up and down the elbow. And then maybe you can just stretch your arms like this, and then you can do just this movement. Right? And now you're seeing Shini, and maybe Shini, you can just now walk. And now you're seeing a different pattern of movement, but you're most of the time not walking like this. You may be walking with your bottle in the hand, and while you're walking, you may be drinking from it as well.
The detail of of twisting.
And here you can see the twisting motions that you're doing. Right, the unscrewing of the bottle cap. And so these patterns need to be interpreted. And because behavior is not just standing still or walking in a straight line, but everything happening at the same time.
But where are you hoping this technology goes?
On a broader thing in general, we want to build technology that understands human behavior and what they're up to make better communication between humans possible, but also make better communications between human and machine possible. We're going to compare what we're doing with what ChatGPT can do. And we're going to give ChatGPT a huge advantage, because instead of telling ChatGPT what the data is actually in all its detail that it cannot make sense of because it's learned to understand text, not movement, we're going to describe to ChatGPT what's going on. And I'm going to use a description that's basically going to make clear what's going on, and any human would understand. You know, any kid can follow what we're doing and give a good guess. And then we're going to see is how good is ChatGPT at understanding human behavior. Based on the action described, the person is most likely using a vending machine. The action of putting the object in a machine likely refers to the insertion of money or payment method. The third action of pressing a button on the machine likely confirms the purchase. Fourth action of getting the object out suggests that the vending machine dispensed the purchase item. Finally, the last action of moving the object towards the person's mouth strongly implies that the purchased item is food or drink that the person is consuming. Now, ChatGPT here got confused about what the object is.
So clearly, ChatGPT has limitations.
The ideal answer here would have been to say the person here is trying to get a drink out of a coffee machine for their own cup.
So the reason why I'm wearing all these sensors today is that you can collect data which is in the form of numbers. Your algorithm will sort through all of that data that we're collecting to find patterns, to learn what my behavior is doing. Why is that useful to you?
We want to help people who need help. A clear application area is healthcare. Be that to develop drugs faster and treatments faster and make them available to people earlier. The other thing is simply to unload overburdened care workers and healthcare workers with doing the task of looking after patients. For many, many diseases, there's currently no drug that treats them because it's too expensive, too risky, and it takes too long to develop it. And so we hope that this technology can help change that.
So why is this useful? It's useful because there are some diseases, neurological diseases like Parkinson's, like dementia, that really affect human behavior. And right now there is very little technology that allows doctors to really understand how human behavior is degenerating as a result of these diseases. So technology like this can really enhance the accuracy of seeing the progress of a disease. And the reason why that's similar to ChatGPT is because ChatGPT looks at words, text, and compares those words to each other, and that's how it learns, machine learns. All of this technology is similar, but it's next level because rather than comparing words, it compares behaviors.